Good day everyone. MCQs part 4. In this video, we shall see few more sums from application of derivatives. F of x is equal to sin x plus cos x. X belongs to 0, pi. 4 options are given to you with absolute maximum, absolute minimum like that. First of all, let me tell you the concept of absolute maxima and minima. For a given polynomial or for any given curve, you may get many maximum points and many minimum points. They are all local maximum and local minimum. But of all the maximas, whichever is the maximum most, that we call as absolute maxima. So there will be only one absolute maxima, similarly only one absolute minima. Here, they are giving you some closed interval. These two are called the end points, okay? That is 0 and pi are end points. We have to find f dash of x equated to 0 and find the critical points or turning points or stationary points, whatever name you call it. Now, in the f of x, you have to substitute the end points and the critical points and you have to find the value. Whichever is numerically the greatest one, that is called the absolute maximum. And whichever is the lowest one, numerically, that is called the absolute minimum. Okay. So now the end points you know. Now let me write my f of x, that is sin x plus cos x. If you differentiate, f dash of x will be cos x minus sin x, right? Let us equate f dash of x to 0. That gives you cos x is equal to sin x, or you will be getting tan x is equal to 1, which gives x is equal to pi by 4. Because within this interval, you will get only pi by 4. You know, tan is positive in first quadrant as well as third quadrant. But here they have given 0 to pi. So I cannot take the third quadrant. So I am taking only one value. If it is 0 to 2 pi, you have to consider the third quadrant also, pi plus pi by 4. Okay. So now here, this is the only critical point I am getting. So now I will write my f of x again, sin x plus cos x. I will find f of 0. I will find f of pi. I will find f of pi by 4, right? These two are the end points and it is the critical point. So f of 0, sin 0 is 0, cos 0 is 1. So I get 1. F of pi, sin pi is 0, cos pi is minus 1. So I get a minus 1. F of pi by 4, sin pi by 4 is 1 by root 2 plus cos pi by 4 is 1 by root 2. So you will get 2 by root 2. That will be equal to root 2. Just see the three values and let us now check this. This not applicable because we don't have this. We don't have this. We don't have this. So let us check the C option. Absolute maximum is root 2. Because root 2, you know the value is 1.414, right? So now this is the absolute maximum value. So this option C is the correct answer. Do you follow? Whether they give you polynomial or whether they give you some trigonometric expression, whatever it is, you take the end points, you find f dash of x and equate it to 0 and find the critical points, substitute the critical points and the end points in f of x, not f dash, okay? Then check the values, whichever is the greatest one, that is the absolute maximum, and whichever is the lowest one, that is the absolute minimum. Hope you have understood this. If x plus y is equal to 8, maximum value of xy is, they have given you 4 options. Actually, this is the simplest statement sum I can say. Now, they have given you x plus y is equal to 8. So, you know there are many possibilities, like 1, 7, 2, 6, 3, 5, like that and all. So, now let us write first x plus y is equal to 8. Now, I have two variables. Let me convert one in terms of the other. So now I can write y is equal to 8 minus x. So I got the y in terms of x. Now you want to find the maximum value of xy. That is the product of x and y. So I will just give the name product. So P is equal to xy. This P I want it to be maximum. Okay. Now instead of this y, let me substitute x into 8 minus x, that is 8x minus x squared. Now you know the concept of maxima minima is the first derivative will be equal to 0. That is common whether it is going to be a maxima or a minima. Then if the second derivative it is greater than 0, then it is minimum. If the second derivative is lesser than 0, it is maximum. Okay, remember this concept. Now P is equal to 8x minus x squared. Let us find what is dP by dx. See, this variable, whatever is on the left hand side should come here. Whatever be the variable here, only one variable should be there. That is why we did the conversion. That variable should come in the denominator. So now I will be getting 8 minus 2x equated to 0. Whether they ask you the maximum value or whether they ask you the minimum value. Now you will get minus 2x is equal to minus 8. That gives you x is equal to 4, right? So your x is 4 we have found out. Only 1 is there, so definitely that should be the 1 for which you will get the maximum value. When x is 4, what will be y? Y is 8 minus x. So 8 minus 4, so y will also be 4. We want the maximum value of xy. So xy will be 4 into 4, 16. So check the options. So option B is the correct answer. Do you understand how to go about this sum? Let us see the third one. The area of a trapezium is defined by f given by f of x is equal to 10 plus x root 100 minus x squared. Then the maximum area in centimeter squared is, and 4 options are given. Actually, it is an example sum in NCERT textbook and they have modified it as an MCQ sum. A part is given like, okay, they have given the area is 10 plus x into root 100 minus x squared. That f of x I will give as a, that is 10 plus x into root 100 minus x squared. I want to find the maximum area. So for that I should know the value of x for which the area is maximum. So let us find out dA by dx. You are having two terms as a product. So you have to use here product rule. So first you will get 10 plus x. Okay. When you differentiate it, first it is 1 by 2 root 100 minus x squared into minus 2x. Then plus root 100 minus x squared into 1. So this is the thing you will be getting. Now let us take LCM and simplify it properly. So I will be getting here these 2 and these 2 I will cancel, and this is the LCM. So there is a minus x here. So you will get minus x into this will be minus 10x. Then or I will keep it as it is. Okay. Minus x squared. Here this into this means the root will go. I will get 100 minus x squared divided by root 100 minus x squared. Equate this to 0 because the dA by dx will be 0 when the area is maximum. So here you will be getting minus x squared. So minus 2x squared minus 10x plus 100, that will be 0 because the denominator when it goes that side, that is automatically 0 into that. So this is the thing. So let us take one minus 2 common out. So we will get x squared plus 5x, right? Then here you will be getting a minus 50. That is equal to 0. How can we factorize it? We can factorize it minus 2 into. This will be x plus 10 into x minus 5, that is equal to 0. So the x values will be either minus 10 or x is equal to 5. Here that x is some dimension of the trapezium, right? So it cannot be negative. So I can omit this value. So the only possible value for me is x is equal to 5. In case you get two positive values, what will you do? Which will you take it as the maximum one? There, you have to go to the second derivative and see which value makes the second derivative lesser than 0. Here anyway, we can omit it and we can take x is equal to 5. So now the area, I will go to the area. I will put x is equal to 5. So 10 plus 5, I am getting 15. Then root 100 minus 25. So I get 15 root 75. Root 75 is what? 25 into 3. So 5 can be taken out. So I will be getting 75 root 3 centimeters squared. Let us check the options. So option C is the correct one. So like this, any sum in your textbook or some other thing that may be modified as an MCQ, that can be modified as a case study sum like that. So if you know the concepts, then you will be able to do them. Let us see the fourth one. The point on the curve y squared is equal to 4x, which is nearest to the point 2, 1 is, and 4 options are given. Actually, you have a similar sum in example in NCERT. This particular sum or this model sum can be asked as a case study sum also, but here it is asked as an MCQ. First, I will teach you the normal way how to proceed. Then I will tell you one shortcut which you can use for MCQ. Okay. So here that y squared is equal to 4x is the given curve for you. Now they have given you one point 2, 1. Let me take A as the point 2, 1. Now on the curve, that is, it is a parabola, you know, there are so many points. In that you want to find the nearest point. Let us take that point as some B. I don't know what it is. I will take it as x1, y1. My purpose is, what is this point B? So that this distance AB will be minimum. Okay. So this we have to use the distance formula which you have studied in your coordinate geometry. Root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Right. But when the distance is minimum, when you square it, that will also be minimum, because if you have the root, no, it will be a bit complicated for us to differentiate and do. So then we can take the distance squared, that is the AB squared, that will be minimum, that will be the smallest. So that point will be the nearest point. That is the concept we are going to make use. Now you know this x1, y1 is a point on this y squared is equal to 4x. So y1 squared will be equal to 4x1, or I can say x1 is equal to y1 squared by 4. So the point B I will take it as, instead of x1 I will write y1 squared by 4 comma y1, so that I will be just having only one variable. So my A is 2 comma 1, my B is y1 squared by 4 comma y1. Okay. Now I am going to find the distance, that I am going to take some s, so that it is easy for me. S squared, that means no root. So I will now write that will be y1 squared by 4 minus 2 the whole square, okay, plus y1 minus 1 the whole squared. This is that s squared. That I will give some other letter, because you cannot differentiate it as 2s into and all, no. That distance square I will represent by some letter. I will write it as some p, that is equal to this y1 squared by 4 minus 2 the whole square plus y1 minus 1 the whole square. Okay. Now we want this p to be minimum, because when the distance is minimum, we want to find the value of x1 and y1. That will be the point. So now I am now going to differentiate it, that is dp by dy1. Here is p and there is y1. You can give the name x1, y1. You can take it as h comma k, whatever you want, but convert it as one variable and then proceed. So here I will be getting 2 into y1 squared by 4 minus 2, okay, that is I am doing it as a function of a function. If you are not comfortable, you can expand it and then also you can do. Any way you can do, that's not a problem. So now I am doing 2 into y1 squared by 4 minus 2 into, when I differentiate this part, I will be getting 2y1 by 4. Here I will be getting 2 into y1 minus 1. Okay. So now let us simplify it and then we will be equating this to 0. So now that dp by dy1 is, okay, here this 2 and this 2 times, this 2 goes. So I am finishing. So I just have y1. So I will be getting y1 cube by 4 minus 2y1, okay, y1 into this and y1 into this. Here I am getting plus 2y1 minus 2, that is equal to 0. Minus 2y1 and plus 2y1 we can cancel. So we will be getting y1 cube by 4 is equal to 2, or y1 cube is equal to 8. That gives y1 is equal to 2, right? When you get y1 is equal to 2, you know x1 is y1 squared by 4. So x1 will be 2 squared, that is 4. 4 by 4. So you will get x1 is equal to 1. So your point will be 1, 2. So which option? D. So option D is the correct answer. So here the concept is to find the nearest point. What do you want actually? The distance between that point and the given point 2, 1, that should be minimum. When the distance is minimum, the square is also minimum. Okay. Now, I told you I will tell you one shortcut, right? Because in the exam, if you do all this, you can do this. This is correct only. But just I am suggesting another way. What you can do is, they have given you 4 points, right? So, quickly what you can do is, you can find the distance between this and this, like that. You can just quickly work out that alone because everything is now numerical. Then you can see which is the nearest one, no? Whichever is the least distance, that point you can say as the one. Like that also you can do, because the MCQs, sometimes no, there are some pluses and some minuses. Here you can use some shortcuts, even without differentiating and other things you will be able to find using the distance formula alone. Okay, are you clear with this sum now? Let me explain few concepts which will be useful to you for tackling case study sums or MCQs. Actually, these are the concepts which are based on your textbook sums only. But let me just explain to you. So, the application of derivatives MCQ, with this part I am finishing, so that I will do for some other chapters. And some big sums I will be doing as case study sums. Okay. Now, the first concept I want you to understand is, if you see this figure, there is a rectangle surmounted by a semicircle, right? Here, this is a rectangle surmounted by an equilateral triangle. When you get like this, 2 figures, one surmounting on the other, they will be giving you the perimeter. In that case, you should be careful. When you calculate the perimeter of this x will come, this y will come, this y will come, and the circular part. This part will not be a part of your perimeter, because many students are making that mistake. So please be clear about it. Perimeter means you start from one end, go like this, like this, like this. Dot in between portion will not come. So the perimeter of this figure will be, you are having 2y, this x, and that portion, no, that's a semicircle. You know, the circumference of a circle is 2 pi r. So half is pi r. Here the radius is x by 2. So pi x by 2. Here this is an equilateral triangle, so all the sides are x. So you will get here 2y plus this is 1x, this is 1x, this is 1x. So whatever perimeter they give, you have to equate it to 2y plus 3x. So remember this concept, okay? So you draw this figure and note this concept in your notebook. The next, actually these are all some results based on your textbook sums. But if you remember, it will be useful for you to answer the MCQs quickly. Okay. So, when a cone is inscribed in a sphere and when the volume of the cone is maximum in such type of sums, the height of the cone h will be equal to 4r by 3, where that r is the radius of the sphere. You have actually two different sums based on this concept, big sums in your textbook. But this result, if you are able to remember, that will help you to do the sums quickly. Here a cylinder is inscribed in a sphere. Okay. Here also the radius of the sphere I have taken as r and the height of the cylinder as h. Here the height of the cylinder, here the cylinder also has the maximum volume. So the height of the cylinder is 2r by root 3. This is also the result of a sum only. But remember this, I will explain this and then I will go to that. Here within a cone there is a cylinder inscribed. Here the cylinder has maximum volume. Now the dimensions of the cone are in small letters, the dimensions of the cylinder are in capital letters. Here the height of the cylinder will be h by 3, that is the height of the cone by 3. So remember this. This also comes as a result, that is when we use the similar triangles and proceed further. So capital H, that is the height of the cylinder, will be 1/3 of the height of the cone. So these three are the inscribed figures have the maximum volume. In that case, we are finding a relation between the dimension, that h, and based on this r here between both the h's. Okay. Now this is again a textbook sum. Here a cone is inscribed in a sphere. What is the relationship between the two volumes? The volume of the cone will be 8 by 27 of the volume of a sphere. Because sometimes what they will do, a big sum they can put as an MCQ and they may give the volume of the cone is equal to 3 by 2 of the volume of 2 by 3, like that. If you know it is 8 by 27, quickly you can tick it. Because these are all textbook sums and you have already done it and you know the answer. Just not much, I don't ask you to by heart too many. But these certain things, at least if you remember, that will help you to tackle the MCQs a bit fast. Okay. So thanks for watching the video. If you have not subscribed, please subscribe so that you will get notifications of further videos. Let us meet in the next video where I will take some other chapter and teach you the MCQs. Thank you again.